For most cancers, the lump a doctor can find and point to is usually not the thing that kills you. What kills you is a single cell that learns to leave it. That escape has a name: metastasis. Cancer traveling through the body and building new colonies in distant organs. It is behind most cancer deaths. Researchers often put the figure around 90%, though the exact share depends on the cancer and on how deaths are counted. The tumor where cancer starts is often survivable. The traveling is what turns it deadly, and it is why doctors race to catch cancer before it spreads. So here is the journey, the exact steps one cell takes to get from a lump to everywhere. Step 1. The cell forgets the rules. A healthy cell obeys two commands from its neighbors: stop growing when you are told, and stay where you belong. It is held in place by adhesion proteins, a kind of molecular glue that locks each cell to the ones around it. Our cell stops listening. The glue lets go, and it starts to change shape, from a neat, boxy, settled cell into a stretched, crawling one built to move. Biologists call that shift the epithelial to mesenchymal transition. It is not an all-or-nothing costume change. It is a dial, and cells can stop part way. But the direction is clear. A stay-put cell is becoming a travel-ready one. Step 2. The breakout. The tumor is caged. Underneath and around it sits the basement membrane, a thin, tough sheet that normally keeps cells in their district, and beyond that, a dense scaffold of fibers that holds tissue together. Our cell cannot push through it, so it dissolves it. It releases enzymes, molecular scissors called matrix metalloproteinases, that cut the scaffold apart, opening a gap. Then it crawls out into open tissue. Step 3. It finds the highway. Threaded through every tissue are blood and lymph vessels. Our cell reaches the wall of a nearby vessel, presses between the flat cells that line it, and slips inside. Getting into the bloodstream is called extravasation. Now it is a passenger in the fastest transport system in the body. And here comes the twist that most people never hear. The bloodstream is not an easy ride. It is the most dangerous place this cell will ever be. The blood tears at it with sheer force from the flow. Immune cells patrol here, and a lone tumor cell is exposed and easy to spot. And there is a quieter killer. Cells like ours are built to live anchored to something. Ripped loose and floating, many trigger their own self-destruct, a death called Anoikis, lost anchor death. So most escaped cells die within hours. Metastasis, for all its danger, is wildly inefficient. The vast majority of escapees never make it. But a few cheat. Instead of traveling alone, some cells break away in a clump and ride together, a huddle called a circulating tumor cell cluster. Wrapped around each other and often cloaked in sticky platelets from the blood, the cells shield one another from the current and from the immune system. In a landmark breast cancer study, these clusters were dozens of times more likely to seed a new tumor than single cells, on the order of 20 to 50 times. The survivors travel in a pack. That fragile advantage is now a target. Because clusters are so much more dangerous than single cells, researchers have started testing whether a drug can pry them apart in the bloodstream. An early idea, not settled treatment, but a sign of how central this one step has become. Step 4. The exit. Far downstream, the vessels narrow into capillaries thinner than the cell itself. The cluster wedges to a stop like a cork in a tube. Then a surviving cell flattens against the wall, pries open a seam between the lining cells, and crawls out into a brand new organ. That exit is extravasation. Against all odds, one traveler has arrived. Which organ, though, is not random? A cell from the gut tends to land in the liver because the blood leaving the gut runs through the liver first. A breast cancer cell often ends up in bone. This is the old idea of seed and soil. A wandering cell is a seed, and it only takes root where the soil, the organ's local conditions, suits it. Stranger still, the original tumor can prepare the ground in advance. It sends out tiny message packets through the blood that make a distant organ leakier and more welcoming, priming the soil before any cell even arrives. Step 5. The colony. And the last surprise. Arriving is not the same as growing. This new organ is alien ground, and building a tumor here is the hardest step of all. Most arriving cells still fail. But some do not die and do not grow either. They go quiet. They fall asleep, alive but barely dividing, hidden in the new tissue for months, years, sometimes decades. That is why cancer can return long after someone was told they were clear. A sleeping cell can wake up. What keeps it asleep and what finally wakes it is one of the hottest questions in cancer research right now. Recent work points to the immune system standing guard over these dormant cells, and to the moment that guard slips as the moment they can stir back to life. So, when a doctor talks about catching cancer before it spreads, this is the race they mean. To stop a cell before it forgets the rules, dissolves its cage, slips into the blood, survives the ride, crawls out somewhere far away, and either grows or waits. The tumor is only the beginning. The journey is the disease. If anything here worries you about your own health, that is a conversation for a real doctor, not a video. What this is for is to let you finally see the machine.